Hello student, the last class we discussed the different concentration terms. Now I am going to discuss the Henry's laws. Henry's laws means the solubility of gases, Henry's law. The solubility of gases in the liquid which is described by this Henry's law. You know there are soda water is there, the scuba diver is there. So all these application based on this Henry's law. That means the solubility of gases in the liquid can be described by Henry's law. So that means what is Henry's law? If you look at the mathematically, the partial pressure of the gases will be equals to the kH into mole fraction of the gas in the liquid. Whereas kH is nothing but a Henry's constant. This is nothing but a Henry's constant. That means the partial pressure of the gases is depend on the mole fraction of the gas in the liquid. So that is what, if you increase the pressure, the more amount of the gas will be soluble in the liquid. That is what you have to understand, because this is directly proportional to mole fraction of gases. Mole fraction of gases more means mole fraction of gases. Suppose if I tell the partial pressure, if the pressure we are increasing, then the mole fraction of gas will increase. That means the number of moles of the gas in the liquid will be more. That is the idea. Mole fraction is nothing but a what? Number of moles of the gas with respect to the total number of moles. Already we discussed the mole fraction, my dear. You got the point? So this way you have to understand. And now what you have to do over here, these things I can write down. P gas by the mole fraction of gas will be equals to kH, which is Henry's constant. So then what do you need to know over here? Mole fraction of gases we can write down like this way. P gas by number of moles of gas by total number of moles. That means the total number of moles will come up will be equals to kH. So that means kH and the number of moles of gases is inversely proportional. So that means if you look at the temperature is directly proportional to kH. This is the relation. The temperature is directly proportional to kH, Henry's constant. If it is increase the temperature, if we increase the temperature, then what will happen, my dear? Henry's constant will be more. If the Henry's constant will be more, then the number of moles of gases will in the liquid will be less. So that means the number of moles of the gases in the liquid will be what? Less. So that is what the relations you have to understand clearly. So that is why kH and the number of moles of gases is inversely proportional, whereas temperature is directly proportional to Henry's constant. If the temperature is more, Henry's constant will be more. As the Henry's constant will be more, the number of moles of the gases in the liquid will be less. Also you can think over is in a physical way. When you are increasing the temperature, then what is happening? The kinetic energy of the gases will be more. As the kinetic energy of the gases will be more, escaping tendency of the gas molecules will be what? More. As the escaping tendency will be more, then the number of moles of the gas in a liquid will be what? Less. That way also you can think over it. So that means both way you can think over it. So that means when we are increasing the temperature, kinetic energy of the gas molecule will be more. As the kinetic energy of the gas molecule will be more, they try to escape from each other. The force of attractions will be very, very negligible. They want to escape out from each another. So that is why when they will escape, then what will happen? In the solution they will be less. So that is why the number of moles of gases in the liquid will be less. Got the point? So this way you have to understand. This is nothing but a Henry's law. You already in the market you used to take Sprite, Coca-Cola, different types of soda water. When you are just open the bottle, there is a huge flow will come, because that means in the high pressure they dissolve the carbon dioxide. So that is what this Henry's law is over there. That pressure increases means the number of moles of the gas which is soluble in the liquid will be more. That is what after opening very high pressure that carbon dioxide coming out, high pressure to the low pressure. Got the point? And now huge application is there in the scuba diver. In a scuba diver, the deep sea diver, they used to go for the deep level of the sea. when the height will, they will go depth of the sea, the density, the pressure will increase as the pressure is nothing but a HdG. Height into density into G is a gravity. So then when they will go depth of the sea, pressure will increase. And then in the high pressure, what will happen, you know, in the backside they have a big tank in the scuba diver. In that tank, there is a particular percentage composition is there. You have to mark up that composition of the gases. Sometimes they used to ask some 11.7% nitrogen, and then helium percentage will be there, and then the oxygen will be there. These are the different component of the gas will be there in a cylinder. Why they used to put these inert gases? The idea is in the high pressure, more of the gas will come into the blood. So that means with the oxygen, helium, nitrogen, they will also come into the bloodstream of the human beings. And then what will happen when they are coming from the deep level of the sea to the up level, that means the pressure will release immediately. What will happen now, and that hydrogen and nitrogen, they will make one bubble inside the liquid. And when they will come into the lower pressure, the gas will comes out. When the gas will comes out, and that bubble, because of that bubble formation in the blood, so then they will not feel that much of jerk. So that is the purpose of giving the gas in the tank in a high pressure. So this is the another applications for this Henry's law, and this is scuba diver and soda water. And this related, they can ask you the problem related to these things. This is nothing but a Henry's law. So then once you understand the Henry's law, then we will proceed for the boiling point, vapor pressures, and to give a clarity during the states of matter, the liquid state, we just give the glimpses of that one. Again we will tell that one, and then we will enter to what is called as a lowering of vapor pressures, relative lowering of vapor pressures, all those things we will tell, and then we will proceed for the nothing but a Raoult's law. Got the point? So then you look at, now I am giving these things is nothing but you need to know what is boiling point, what is vapor pressures, and what is lowering of vapor pressures, what is relative lowering of vapor pressures. We need to know all those things. So first of all, the things what we need to know, what is boiling point of a liquid. Boiling point of liquid, you need to know. So if you look at, there is one liquid is there. This is a liquid. So only I am telling this is nothing but a pure water. Pure water. And here container is there. And now here you are giving the heating. You are put heating over here. Now here the vapor pressure of water, Vp means vapor pressure of water, I am telling pure water is nothing but a P0. Clear? And now another container is there. And here the lid is there, and then here I am telling that H2O plus NaCl, that means salt solution is there. And here vapor pressure, I am telling PS. And can you tell me which one is the highest vapor pressures? Generally we know P0 is greater than PS. Why? Why we need to know these things? First of all, we need to know what is the vaporization process. You know, when you are applying the heat, then in the surface molecule, so they have an unbalanced force of attraction. This direction they have always force of attraction. If you consider any bulk molecule, all the direction molecule will be there. All the direction molecule will be there. They don't have any unbalanced force of attraction. But the molecule which is there in a surface, they have a unbalanced force of attraction towards the bulk of the liquid. Because of this unbalanced force of attractions, they will have a very high energy state. When you are putting the heat, the molecule already is there in a tension and high energy, and then when you are applying the heat, the molecule easily leave the surface and they will come over here. Then this process is called as a vaporization process. Liquid to vapor. And then this molecule is collide among themselves and also walls of the container. When they will collide, then they will lose the energy. Again, they will come from vapor to liquid. Again, they will come back from vapor to liquid. This process is called as a condensation. This process is called as a condensation. Continuously, this vaporization, condensation, vaporization, condensation is going on. So there will be one point will be reached when the rate of vaporizations will be equal to the rate of condensation. That means the equilibrium will be reached between the liquid and the vapor. The equilibrium will be reached. At that point, the rate of vaporizations will be equal to the rate of condensation. At that point, pressure exerted by vapor, pressure exerted by vapor, pressure exerted by vapor is nothing but a vapor pressure. So that means when there is a rate of vaporizations will be equal to the rate of condensation. At that point, pressure exerted by the vapor is nothing but a vapor pressure. And now you look at this vaporization process is directly proportional to the availability of the solvent molecule on the surface. It is a surface phenomena. So vaporization process is a surface phenomena, whereas boiling point is a bulk phenomena. So vaporization process is a surface phenomena. So vaporization will be nothing but a depend on the availability of the solvent molecule in the surface. So that is why if the more number of solvent molecule available over here, immediately the lot of vapor will be produced, as the vapor pressure also will be very high. But in case of a solution, you look at here there is a H2O molecule. Suppose here there is a H2O molecule. This is H2O molecule, and then there will be a NaCl molecule, because it is a solution. H2O molecule, NaCl molecule, H2O molecule, NaCl molecule. So then if you look at H2O, this is H2O and this is NaCl. But here all molecule is nothing but what? H2O molecule. So that is why in the solution availability of the solvent molecule in the surface is less. So that is why at the same temperature the produced vapor will be less, vapor pressure will be less. So that is why the pure solvent has a more vapor pressure compared to the solution, as the availability of the solvent molecule in the solution in the surface will be less, because in the solution solute molecule also will be there in the surface. So that is why availability of the solvent molecule will be less. As the availability of the solvent molecule will be less, so then the vapor generation will be less, vapor pressure will be less. So that is why pure solvent has a always higher vapor pressure compared to solution. Got the point, my dear? That is why the boiling point of salt water is more compared to the boiling point of a pure water. What is boiling point? The boiling point is that temperature when the vapor pressure will be equal to the atmospheric pressure. So that is what you look at. Atmospheric pressure, you know, 1 atmosphere. So then to reach the 1 atmosphere, the vapor, it need 100 degrees centigrade of temperatures. That means when it will reach, then the boiling will start. But here at 100 degrees centigrade of temperature, what vapor pressure will be created, that vapor pressure will not equal to the atmospheric pressure, then the liquid will not boil, because here the rate of vaporization will be less, and the availability of the solvent molecule in the surface will be less, vapor pressure will be less. So that is why vapor pressure, substantial amount of vapor pressure will not be there, which can be equal to the 1 atmospheric pressure. Then if you need more temperature, if you put, then only more vapor will be generated, then only vapor pressure will be equal to the atmospheric pressure, then only it will start boiling. That is why the boiling point of a salt around 120 degrees centigrade, whereas the boiling point of pure water will be 100 degrees centigrade. Got the point, my dear student? So these are the understanding. First you need to know the vapor pressure of a pure solvent will be greater than the vapor pressure of a solution. Why? All those logic I explain over here. Then we need to know what is lowering of vapor pressure. So let us focus what is lowering of vapor pressures. Lowering of vapor pressures. lowering of vapor pressures. So, if you look at in a pure solvent, this is a pure solvent. In pure solvent, vapor pressure is P naught, and if there is a solution is there, this is a solution, vapor pressure is Ps. So then the lowering, and we know P naught is greater than Ps, and then lowering of vapor pressures, vapor pressure Vp will be equal to how much? P naught minus Ps. Because of adding of solute, how much vapor is lowering, that is at the same temperature, is nothing but a what? P naught minus Ps. This is called as a lowering of vapor pressure. This much lowering is there. And then what is relative lowering of vapor pressures? So these things we can write down delta P. These things we can write down what? Delta P. And then with respect to this, the original vapor pressure of a pure solvent, with respect to how much lowering is there, that is called as a relative lowering of Vp, vapor pressure, or it is in short form is called as a RLVP. So relative lowering of vapor pressures. So with respect to the pure solvent of water, how much lowering of vapor pressure is there, that ratio is called as a RLVP. Got the point, my dear student? So this is nothing but a RLVP. And now once you understand these things, then we are proceeding to explain the Raoult's law. So let us focus on the Raoult's law. The Raoult's law you have to understand very easiest way. I will explain very easily, very easily. You will understand in a single shot itself. So this Raoult's law, we need to know what is Raoult's law, and I will explain in very easiest manner. The Raoult's law. What is Raoult's law? The Raoult's law is nothing but a, you need to know. Here what will happen, my dear, in Raoult's law, the thing is for the non-volatile, non-reacting two liquid mixture. Non-reacting two liquid mixture you have to take. And then suppose I am taking the liquid A, this is there in liquid A. When there is a pure form, the vapor pressure is nothing but a P naught. You got the point? This is a pure liquid A, and vapor pressures is P naught. Another is there, the liquid B, this is liquid B, in pure state, the vapor pressure is PB naught. You got the point, my dear student? And now what I am telling, when you are mixing these two liquid, and here you have a liquid A plus liquid B, which are non-reacting to each other. Here the vapor pressure I am telling is nothing but how much? P total, and here these things will be nothing but what? The vapor pressure contributed by A in the solution I am telling PA plus the vapor pressure contributed by liquid B is nothing but a PB. Got the point, my dear? So now in pure state PA naught, and in the solution vapor pressure of liquid A will be nothing but a PA. And this PA is directly proportional to mole fractions of A. If you remove this proportionality, then we can write down PA will be equals to PA naught into mole fraction of A. Vapor pressure of a pure liquid is a constant that we are taking as a proportionality constant. So then PA will be equals to PA naught into mole fraction of A. Likewise, we can write down PB here itself, PB proportional to mole fraction of B. So then PB will be equals to PB naught into mole fraction of B. We can write down. So then P total will be equals to what? PA plus PB is nothing but a PA naught into mole fraction of A plus Pb naught into mole fraction of B. We can write down these things, got my dear student? So this is nothing but the Raoult's law for the ideal solution mixture. And now these things, they used to put a problem over there. How they will give the problem? Let us focus the problems. So then, how they will give you, and this is for the ideal case. This is for ideal case. This is for the ideal case. There will be two non-reacting liquid will be there, and this is the ideal scenario. And in this ideal case, what will happen? You need to remember the delta H of mixing will be equals to 0. Delta V of mixing will be equals to 0. The reaction is spontaneous. That is why delta G will be less than 0, negative. And then two liquid is mixing, then the number of molecules will be more. Chaosness will be more. So that is why delta S will be always will be positive, greater than 0. Got the point, my dear? Whenever in two solution, non-reacting solution is mixing and they are maintaining the ideal Raoult's law, that is for ideal solution, that is for ideal case, in that case condition, delta H of mixing will be what? 0. Delta V of mixing will be what? 0. Delta G is less than 0 because the process is a spontaneous process. So, because why spontaneous process? When you are mixing the two liquid, the some sort of interactions will be there. That means it's like a bond formation, like idea will be there. Bond formation means what? The process will be spontaneous one. So that is why delta G will be less than 0, and the more number of molecules come into contact, chaosness is increasing, disorderness is increasing, delta S is greater than 0. So that is what you have to understand over here. Now, after understanding these things, how they can give the problem, let us focus for that one. Then we will go, after these things, then we will go for positive deviation and then only the negative deviations from the Raoult's law. So then if you look at how they will give the problems, already we know P total is nothing but a PT, PA plus PB, and then these things we can write down. PT will be equals to PA naught into mole fraction of A plus PB naught into mole fraction of B. So we can write down these things. Then this way we can write down again PA naught mole fraction of A plus mole fraction of B will be equals to 1, like the two component is there. So then if you add up both the mole fraction, it will give you 1, total will be 1, clear? So that is why we can write down like this way, Pa into mole fraction of A plus Pb into 1 minus mole fraction of A, that is nothing but a what? The mole fraction of B. So mole fraction of B is nothing but a 1 minus mole fraction of A. So then we can write down Pa naught mole fraction of A plus Pb naught minus Pb naught mole fraction of A. So then we can write down here itself Pb naught, here already we put over here, instead of mole fraction of B, we put it over here 1 minus mole fraction of A. So then Pb naught plus we can write down mole fraction of A will be equals to Pa naught minus Pb naught. We can write down these things. You look at, this is Pb naught plus, these things is plus, so this is plus, and these things is minus, plus minus minus. Why I write down these things? Instead of this we can write down simply this way, plus Pa naught minus Pb naught is mole fraction of A. This way we can write down. So this is nothing but a P total. Same thing can be done in terms of a mole fraction of B also we can write down. Because 1 year they give the problem like this, that 160 will be equals to 120 plus 120 plus 180 mole fraction of A. So they are giving like this. Then they are asking what is Pa naught and what is Pb naught. Like that they put the questions. So that means already we reached over here. You look at this way, you have to write down. From here itself we are coming over here. So that means you look at P total is nothing but a 160. So then PB naught is nothing but how much? These things, if you compare this equation and this equation, we can write down PB naught will be equals to how much? 120. Got the point? And then PA naught minus PB naught is nothing but how much? 180. So then we can write down PA naught minus PB naught will be equals to 180. And then PA naught will be equals to 180 plus PB naught. PB naught already we got it 120. So then 180 plus 120 will be equals to 300. So then we got the PA naught 300. PB naught is 120. Got the point? So that is what, if they ask you this type of questions, they are giving that equations and then they will ask you the question, what is the PA naught and PB naught? So that is what I am just to open up, what are the dimension, they can go and they can ask the questions. But everything is coming from the basic idea of a Raoult's law. Clear, my dear student? So this is nothing but the ideal cases. Then we will proceed for the positive deviations and the negative deviations. So let us focus for the negative deviation first and then we will go for the positive deviation from the ideal cases of the Raoult's law. So then the ideal case, if I put a picture wise I will put and then I will explain one by one. The ideal case picture already, if you look at the ideal picture of a Raoult's law, that ideal case already we explained. Ideal case picture, if you put vapor pressure versus compositions. This is vapor pressure is a this direction and this is a compositions. And here the mole fraction of A will be equals to 1, mole fraction of B will be equals to 0. Here the mole fraction of A will be equals to 0, mole fraction of B will be equals to 1. And then I am writing like this, and then I am writing like this, and I am writing like this. So if you look at over here, this point is nothing but a PA naught, and this point is nothing but a PB naught, and then if you look at this line is nothing but a PA, this line is nothing but a PB, and this is nothing but a P total will be equals to PA plus PB, and PA will be equals to PA naught into mole fraction of A, and already we know PT will be nothing but a what? PT will be equals to PA plus PB, and then this will be nothing but a PA naught into mole fraction of A, PB naught into mole fraction of B. Already we know these things. So that is what this mole fraction is nothing but the mole fraction of the liquid A in a liquid mixture. Got the point? So then immediately we will get these things. This is for the ideal case. Now, and for the ideal cases already what I told, delta H of mixing will be equals to 0, delta V of mixing will be equals to 0, delta G less than 0 spontaneous process, delta S greater than 0. Already we explained this is for the ideal cases. For the positive deviations, or the first you look at for negative deviations. Negative deviations, what will happen, my dear? You can look at here itself, if you look at here what we are telling PA naught. Already we know P total will be equals to what? PA naught into mole fraction of A plus PB naught into mole fraction of B, and this mole fraction of B here would be nothing but a what? 0. That means this entire part will be 0, and this is nothing but a 1. So then PT will be equals to what, my dear? Will be equals to PA naught. So that is why this point is nothing but a what? PA naught. Got the point, my dear? Simple logic. So same way this point is nothing but a what? PB naught. Understand clearly? And then we are discussing negative deviations. If you look at the negative deviations, in that case, the same way I am drawing the picture, same way we are drawing the picture, and then here this point is same PA naught, and this is nothing but a mole fraction of A, 1, mole fraction of B in the mixture will be 0. At this point mole fraction of A is 0, mole fraction of B will be equals to 1, and now this point will be PB naught. This is nothing but a PT will be equals to PA plus PB, and PA will be equals to PA naught into mole fraction of A. This line is PA, this line is PB. Already you know all those things. Now they are telling the negative deviation. Negative deviation means the vapor pressure this direction, compositions this direction, compositions this directions. And now the negative deviation means this is the ideal line. They will below from the ideal line. And here also will be below from the ideal line. Here also will be below from the ideal line. This is called as a negative deviations. There as a certain liquid mixture is there. Like if I say HNO3 plus water. If I take acetone plus aniline. There are n number of mixture is there in the book. You can proceed and you can study that mixture. You have to mug up that data. If they ask the informative question, which of the following mixture used to show the negative deviation from the Raoult's law, that is what you have to mug up that things. Got the point? And now this is the mixture of liquid. They used to show the negative deviation. That means the vapor pressure of the mixture will be lesser than compared to ideal scenario of a Raoult's law. Why these things is happening? The reason is, if you look at vapor pressure is less means what? The force of attractions between the A and B, the two different types of molecules, will be very, very greater than the force of attraction between the AA or the force of attraction between BB. So as the force of attraction is very high between the two liquid mixture, then what will happen? If you when you are applying the heat, they easily will not go to the vapor phase. So when they will not go to the vapor phase, at the same temperature in an ideal case, their vapor pressure will be less compared to the ideal one. That is why their vapor pressure is less. That is why they used to show what deviation? Negative deviation, my dear. So that is why this is the punching point you have to understand why they used to show the negative deviation. The force of attraction between the liquid mixture is very, very high. As the force of attraction is very high, then what will happen? They will not go to the easily to the vapor phase. When they will not go to the vapor phase, they will produce less vapor pressure. When they will produce the less vapor pressure, their vapor pressure will be below the ideal line. That means they used to show the negative deviation, my dear. Got the point? So that is what you have to understand. So then immediately you will got this idea. And when the negative deviation will come into the picture, then delta H of mixing will be what? Delta H of mixing will be less than 0. When the force of attraction is more, there is a bond formation will be there. Bond formation is a exothermic process. Heat will be released from the system. Heat release means what? Delta H is negative, my dear. That is why delta H is less than 0. And then delta V of mixing will be less than 0. As the force of attraction is very high, the molecule will be very close to each other. When the molecule will be very close to each other, volume will decrease. So that is why delta V of mixing will be less than 0. But the delta G is a spontaneous process, always less than 0. Delta S spontaneous process is greater than 0. In ideal cases, you look at delta H is 0. Delta V is 0, delta G and delta S always will be same. Less than 0 delta G, delta S is greater than 0. But in case of a negative deviation, we observe these things. So then once you understand the negative deviation, then we will go for the positive deviation, my dear. In case of a positive deviation, what is happening? Then once you understand the negative deviation, then we can go for the positive deviation. From the ideal case of a Raoult's law, from the positive deviation. If you look at the positive deviations, then the same way I am drawing over here. So this is nothing but the same way I am drawing. So this point is PA naught. This is nothing but a PT will be equals to PA plus PB, and this thing is nothing but a PA, this thing is nothing but a PB, and this point is nothing but a mole fraction of A 1, mole fraction of B 0. The same way mole fraction of A will be 0, mole fraction of B will be equals to 1. This point is PB naught. And then positive deviation means you know this direction vapor pressure and this direction compositions. And then if you look at very nicely, then positive deviation means what? The vapor pressure will be higher than the ideal value. That is nothing but a positive deviation. This way, this line will be this way, this line will be this way. This is nothing but a positive deviations. Now if you look at the positive deviation, there is a mixture of liquid is there. Nothing but a what? Nothing but a the C2H5 OH plus water, then CH3OH plus water, then we can say acetone plus carbon disulfide. There is a n number of mixture, carbon tetrachloride, benzene. So like that mixture of liquid will be there, which used to show the positive deviations. So in positive deviation, why this positive deviation is arising? The idea you need to know, the force of attractions of A and B will be lesser than the force of attraction between AA or the force of attraction between BB. That means in a mixture of liquid, the force of attraction between AB will be lesser compared to when there will be there in a pure state. As the force of attraction is lesser, then what will happen? When you will apply the heat, the force of attraction is lesser means immediately they will go to the vapor phase. When immediately they will go to the vapor phase, the vapor pressure will be very high compared to ideal cases. So that is why the vapor pressure line, if you look at, is go above the ideal line. That is nothing but they used to show the positive deviations. So that is what you have to understand these things. And now here we can say the force of attraction between A and B is lesser, whereas escaping tendency of A and B is higher compared to A or compared to BB. As the escaping tendency is higher, they will produce very high vapor pressure. So that means they will go above the ideal line. So that is why this is so used to show the positive behavior. And now in this case we can discuss as the delta H of mixing will be what? Greater than 0. That means here the force of attraction is not there. So that is why the bond formation will be not there, and positive deviation means the repulsive force will be strong. So that is what we can say, the delta H of mixing will be greater than 0. As their repulsing force is more, they will be away to each other. When they will away to each other, volume also will be what? Greater than 0. And then delta G as it is, spontaneous process, less than 0, delta S is greater than 0. These things will be there. In case of a ideal case, delta H 0, delta V 0, delta G less than 0, delta S greater than 0. Very important point. Several times they put a questions over here. But in case of a positive deviation, delta H greater than 0, delta V greater than 0, delta G less than 0, delta S greater than 0. Negative deviation, delta H less than 0, delta V less than 0, delta G less than 0, delta S greater than 0. So these things you have to understand. So this is nothing but the entire Raoult's law. They are ideal case, positive deviation, negative deviation, everything I explained very simple way. I hope you understand, my dear student. So the next class I am going to discuss is nothing but I will start with the different colligative properties and the Van 't Hoff factors. So I hope understand everybody. Thank you everyone. Thank you all.